Hi everyone. So for the Chapter 7 video, I have a couple of challenges for myself. One, I'm going to try to explain it in 7 minutes or less. And also, I will try to explain each concept while still holding my video device. So here it goes. All right, so the first rule that we're going to look at is multiplying exponents, and with the same base, of course. So this is going to be a challenge. We've got x times x, that's x squared, times x to the third, so times x times x times x. Okay, so that's 5 x's, right? So that's equal to x to the 5th power. Okay, so when you multiply exponents with the same base, you just add the exponents. Next, we have power to a power. Okay, so if we take x squared to the 3rd power, that's like taking
x squared times x squared times x squared. Okay, or x times x times x times x times x times x. This actually is challenging.
We have 6 x's there. Okay, and you can look here, we could add those and get 6. But if you look up here, we've got 2 and 3. So this is equal to x to the 6th. So when you're taking power to a power, you just multiply the exponents. And now we have power of a product. And when we have an expression and we take the whole thing to an exponent, we have to take each individual piece to that exponent.
So if you look at this, we're going to take 2 to the 3rd power, and we're going to take x to the 3rd power, and we're going to take y squared to the 3rd power, and we're going to take z to the 3rd power. Okay, so we have to take each piece to that power. So 2 to the 3rd power is 8, x to the 3rd is x to the 9th, y squared to the 3rd is y to the 6th, and z to the 3rd is z to the 3rd. And that's our final answer.
And now we have a quotient. If we have a quotient, we could just subtract the exponents. But one way that people like to look at it is as if these two expressions are going to battle. So if you take these to battle, if you look at the x's, if they would battle each other, what side would win? The top or the bottom? Yes, the top, or the numerator. Okay, and if they fight each other off, there would be 2 left on the top. So I'm going to put x squared on the top. Now if I look at my y's, the denominator would win, and there'd be 8. And then we look at the z's, and if they battle each other, then the top would win, and so we would get z to the 4th power. Okay, so our final answer would be x squared z to the 4th over y to the 8th. We can't forget about 0 exponents and negative exponents. So first, with 0 exponents, anything to the 0 power is 1. For negative exponents, in order to get rid of the negative exponent, because they're actually illegal, you have to switch the location. So if they're on the top of a fraction, you put them on the bottom. Bottom, you move them to the top. So this one would actually be 1 over 5 squared, or 1 over 25. And then if we look at this one, everything is negative, so we need to change the location of everything. So it becomes c squared d to the 3rd over a to the 3rd b to the 4th. Now try some. Pause your video and see how you do. How did you do? For number 1, you need to square everything and then you can simplify. For number 2, you can cancel the m's. For number 3, you need to first do each individual piece and then put them together. And for number 4, I flipped it over and then took everything to the positive 3rd power. But you could simplify before you take everything to the 3rd power. But then you end up with y to the 3rd power over x to the 6th power. And now we have rational exponents and roots. Okay, and so for these, the little number on the outside, that's the root. Okay, and so for these, if you're going to make a rational exponent, so make your exponent a fraction. Just one moment.
Good afternoon, staff and students.
So if you're going to write a rational exponent of fraction for your exponent, you're going to keep the x as the base, and then your root is your denominator, and the exponent is the numerator. Okay, so now if we go the opposite way, we said the root is the denominator, so it's the fifth root of a to the fourth power. All right, so now let's look at something like this. If we have the third root of, or the cube root of 8x to the third, we can break that down, and it's
The cube root of 8 times the cube root of x to the third. Okay, the cube root
of 8 is 2. The cube root of x to the third is actually x, so this is our answer here. Okay, and then one more. We have 4x squared all to the half power. And remember this, the denominator is the root, so it's actually the square root of all of this. And so I want to show you two different ways. Okay, so I'm going to show you the square root of 4x squared.
like that. Okay, so that's the square root of 4 times the square root of x squared. Square root of 4 is 2, right? And the square root of x squared is x.
But if we did it this way, where we take everything to the exponent, we'd have
4 to the 1/2 power times x, and then 2 x squared to the 1/2 power, we multiply the exponents, so 2 times 1/2 is just 1. Okay, right? And 4 to the 1/2 power is the square root of 4, and so that's 2x. Okay, so that's just two different ways. There's a few more things. We're kind of running out of time. Here's scientific notation. And for scientific notation, you need to make a decimal after the first digit. Okay, and then you need to see if it is a large number, it's going to be times 10 to a positive exponent. And so you just look and see how many places you would move the decimal. So there's 3, 6, 9, so this would be 2.521 times 10 to the 9th. This one here, we are going to put this number in the standard form. So here, this is a negative exponent, so we're going to move it to the left, 8 places. I can only move it 1, so I need to add 7 zeros. 1, 2, 3, 4, 5, 6, 7, and then 6, 2, 3, 4. I put my decimal here, and I put a 0 in front. Okay, now we're over here. Exponential growth and exponential decay.
Remember, these are things that increase or decrease not at a steady rate, but kind of like a pandemic. They increase exponentially or decrease exponentially. Okay, and then compound interest is a way that your money can increase exponentially. Okay, and those formulas will be there for you. But for the exponential growth and exponential decay formulas, y is going to be the final amount, a is the initial amount, r is the rate, t is time. Compound interest, a is your final amount, p is the principal or the original amount, r is still rate, n is how many times your interest is compounded, and then t is time. Okay, and finally we have geometric sequences. We are going to find the 10th term of this sequence, so 2, 8, 32, using this formula right here. Okay, so if we're looking at the nth term, this is your formula. Okay, so we have the first term times the r is the common ratio, to the n minus 1 power. So if we're finding the 10th term, then that's going to be times the first, it's going to be the first term, which is 2, times the common ratio. And the common ratio is whatever we're multiplying by each time. That's how you get a geometric sequence. And so in this case, our r would be 4 to the n minus 1, so to the 10 minus 1 power, so to the 9th power. Okay, so we're going to grab a calculator.
And we're going to go 4. Nope, let's do that first. Oh, this is difficult.
4 to the 9th power is 262,144. We're going to multiply by that by 2. And that means that our 10th term is 524,288.
That is the 10th term of the sequence, and now we're done with chapter 7.
Did I do this in under 7 minutes?